Introduction to Statistics, Chapter 5, Probability, Section 5.2, the addition rule and complements. Two events are disjoint or mutually exclusive if they have no outcomes in common. That is, they may not occur at the same time. A Venn diagram may be used to represent events as circles enclosed in a rectangle. The rectangle will represent the sample space and the circles will represent the events. Venn diagram for two events that are disjoint or mutually exclusive. It would be a rectangle with two circles that do not overlap each other because they are disjoint. They have nothing in common. Example, if a sample space is a set of 1 through 7, event E is a set of 1 through 5, and event F is a set of 2, 6. If you look at E and you look at F carefully, they have no outcomes in common, so they are disjoint. So the Venn diagram would be the following. It would be the sample space, the rectangle would be the sample space. We draw a circle for event E, draw a circle for event F. They would not touch because they have nothing in common. Now you would take and put the outcomes in event E, 1, 3, 5, put the outcomes in event F, 2, 6. Now we look. Are there any outcomes in the sample space we did not put in E and F? If there are, then we put them out in the sample space. So in this case, 4, 7. So this would be the Venn diagram for this example. Now, if two events E and F are disjoint or mutually exclusive, then the probability of E or F equals the probability of E plus the probability of F. An example. If the sample space is a set of 1 through 10, the event E is a set of 1 through 5, and event F is the set of 4, 7. Find the probability of E or F. Well, since E and F are mutually exclusive, if we look at E and F, they have nothing in common, so they're mutually exclusive. So the probability of E or F is going to equal the probability of E plus the probability of F. If I go to a Venn diagram, I put 1, 3, 5 in E, I put 4, 7 in F. That leaves 2, 6, 8, 9, 10 outside of E and F in the sample space. Now, probability of E is 3 out of 10 or 0.3. Probability of F is 2 out of 10 or 0.2. So the probability of E or F is going to be the probability of E, 0.3, plus the probability of F, 0.2, which is 0.5. Two events are not disjoint or not mutually exclusive if they have one or more outcomes in common. In other words, they may occur at the same time. Venn diagram of two events that are not disjoint or not mutually exclusive. In this case, you would draw your rectangle. This time, the two circles for E and F would overlap. They would have an area in common because they're not disjoint, not mutually exclusive. And event E would be the part in blue there. Event F would be the green. And if you notice, we counted that center section twice. So that would be E and F would be the yellow part. An example, if the sample space is 1 through 10, event E is a set of 1, 3, 5, 8, and event F is a set of 1, 2, 8. Now if we look closely at event E and event F, you notice there are common outcomes. 1 and 8 is common to both. So we're going to have not disjoint, not mutually exclusive. So we draw E, draw F where they overlap. Now I want to put the elements in, the outcomes. So what outcomes are common to both E and F? 1 and 8. So I put those in. Now what other outcomes do I need in E? Well, 1, 8's there, but I also need 3, 5. So I need to enter 3, 5 into E. And then F is 1, 2, 8, so I enter the 2 for F. Now, is there anything missing in our sample space? Well, I've got 1, 2, 3, 5, 8. So it looks like 4, 6, 7, 9, 10's missing. So I have to put 4, 6, 7, 9, 10 out here in the sample space. Now, if two events E and F are not disjoint or not mutually exclusive, then the probability of E or F equals the probability of E plus the probability of F minus the probability E and F. The reason that we're going to have to subtract this is we count that area that's common to both twice. So we got to subtract it out once. So if S is the probability, if the S is the sample space, 1 through 10, E is the outcomes 1, 2, 3, 5, F is the outcomes 1, 4, 7, find the probability of E or F. Well, we look at E and F. They are not mutually exclusive. So in this case, then, the probability of E or F is going to be the probability of E plus the probability of F minus the probability of E and F. So the Venn diagram here with all the numbers filled in for E and F. Now what do I want? The probability of E, if I look at the diagram, is 4 out of 10, 0.4. Probability of F is 3/10. Now, what's the probability of E and F? There's only one in that area, so that's 1/10 or 0.1. So now I would add probability of E plus the probability of F and subtract the probability of E and F. And I would get 0.6 for my answer. This gives you a visual and also shows you how to get it. You do not need to draw the Venn diagram, do the visual, it's just a help. Complement rule. The complement of E, denoted E superscript C, is all outcomes in the sample space S that are not in event E. The complement of event E in the following Venn diagram would be the part in yellow. So if we draw a Venn diagram with event E, everything outside of E that's still in the sample space would be the complement of E. An example, if the sample space is a set of 1 through 10 and E is the set of 1, 2, 3, 5, find the complement of E. Well, if I drew this, this is what the Venn diagram would look like. Now, what's outside of E but in the sample space? It looks like it's 4, 6, 7, 8, 9, 10. So the complement of E would be the set of 4, 6, 7, 8, 9, 10. If E represents any event and the complement of E represents the complement of E, then probability of E plus the probability of E complement equals 1. And the probability of E complement is equal to 1 minus the probability of E. Also, probability of E is going to equal 1 minus the probability of E complement. So if I know the probability of E or I know the probability of E complement, I can always find the other one. Now an example, if the probability of E is 0.28, find the probability of E complement. So probability of E complement is going to be 1 minus the probability of E, which is 1 minus 0.28, which is 0.72. Now, using Venn diagrams to problem solve, you will first need to understand regions of a Venn diagram. You know, if you had a Venn diagram illustrating one event, it's going to split into two regions, A and B. A is in event E and B is in the complement of E. So A represents the outcomes in event E or the probability of E. You could write it either as the event outcomes or the probability. B represents the outcomes not in event E or the probability of E complement. Now, a Venn diagram illustrating two disjoint or mutually exclusive events. If you recall, this would be a rectangle with E and F inside not touching each other. So this has three regions, A, B, and C. A represents outcomes in event E or the probability of E. B represents outcomes in event F or the probability of F. Now C represents outcomes not in event E or event F. This could also be thought of as a probability not in E or F. Now let's look at a Venn diagram illustrating two events that are not disjoint or not mutually exclusive. So in this case, it's a rectangle for the sample space. We have a circle for E, circle for F, but this time they overlap each other because they have a part in common. They are not disjoint. So this has four regions, A, B, C, D. So let's start with A. A represents outcomes in event E that are not in event F, or probability of E and not in F. B represents outcomes in event E and in event F, or the probability of E and F. C represents event F, outcomes that are in event F that are not in event E, or the probability of F and not in E. And D represents outcomes not in event E or event F, or the probability not in E or F. Venn diagram illustrating two events that are not disjoint or not mutually exclusive. Okay, again, we have the four areas. If we look at this, A we said was the probability of E not in F. B was the probability of E and F. C was the probability of F and not in E. D was the probability not in E or F. Now, a note, probability of E is going to be the probability of E and not in F plus the probability of E and F. That's region A plus region B. Probability of F is going to be the probability of F and not in E, and the probability of E and F. So that's regions B and C added together. So the probability of E or F is going to be the probability of E not in F plus the probability of E and F plus the probability of F and not in E. So that's going to be regions A, B, and C added together will be your probability of E or F. Okay, let's look at a problem. If probability of E equals 0.25, probability of F equals 0.45, and probability of E and F equals 0.15. Find probability of E or F. Well, first off, draw a Venn diagram. The probability of E and F equals 0.15 implies not disjoint. So we draw a Venn diagram with event E, event F overlapping. Second, enter given probabilities into the proper regions. Always start in the center. So the probability of E and F is 0.15. Now, I want to move out. The next probability of E was 0.25, but remember, that's going to be two sections added together. So I have to take the probability of E and subtract probability of E and F to get that region. And the next region on the other side, this would be the probability of F minus the probability of E and F, 0.3. Now we solve for probability of E or F, and what did we say that was? That was all three of those regions added up. So it's 0.10 plus 0.15 plus 0.30, which is 0.55. Problem 2. If the probability of E equals 0.25, probability of F equals 0.45, probability of E or F equals 0.6. Find probability of E and F. So first, we want to draw a Venn diagram, but we have to know whether they're disjoint sets or not disjoint. So, in this case, how do we check? If the probability of E and the probability of F is greater than the probability of E or F, that implies not disjoint or not mutually exclusive. So we draw the Venn diagram with E and F overlapping. Second, realize that the probability of E and F is going to be the probability of E plus the probability of F minus the probability of E or F if probability of E plus probability of F is greater than probability of E or F. So in this case, what I'm going to do is I'm going to take the probability of E plus the probability of F, add them together, and then subtract the probability of E or F. So I take 0.25 plus 0.45 minus 0.6, and I end up with 0.1. So that means the probability of that one came up out of place. The probability of E and F would be 0.1. The probability of E minus probability of E and F is 0.15, and those two areas would add up to be the probability of E. If you add those two together, you get 0.25. And on the other side, you would get 0.35. And if you add 0.1, 0.35, you get to 0.45 for the probability of F. And now, if I look at this, the probability of E or F is equal to 0.15 plus 0.1 plus 0.35, which is 0.6, is what was supposed to be in the original problem. Okay. Example 3. If the probability of E equals 0.60, probability of E or F equals 0.85, and probability of E and F equals 0.05, find probability of F. Well, draw the Venn diagram. Well, the probability of E and F equals 0.05 implies not disjoint. So we draw our Venn diagram with E and F overlapping. Second, enter given probabilities into the regions. Okay, we want to start in the center always. So probability of E and F is 0.05. Now, next, probability of E minus probability of E and F would give me 0.55 for that region. If you notice, 0.55, 0.05 add up to be the 0.60, which is the probability of E. Next, realize probability of F minus the probability of E and F equals the probability of E or F minus the probability of E. Okay, so I'm going to take the probability of E or F, which is 0.85, that was given in the problem, minus the probability of E, which is 0.60, which gives me 0.25. So that would give me this other region here, 0.25. Now, realize probability of F is probability of E and F plus the probability of F minus probability of E and F. So that's going to be the section 0.05 plus 0.25, which is 0.30 for your answer. All right, this brings us to the end of section 5.2.